Hi, my name is John Grimes and I'm an engineer at the Australian eHealth Research Centre at CSIRO, Australia's National Science Agency. Today I'm going to give you an overview of our work on a tool called Pathling that we have developed to make it easier to use FHIR and clinical terminology within health data analytics. We started working in this space in 2018 because we saw that while FHIR was gaining a lot of adoption in the data interoperability space, there was still a lack of tools to assist with the use of this data for analytic purposes. There were three main problems that we saw there would be value in providing a standards-based open source solution for. The first was the problem of having some sort of standard and generalized method of making FHIR data available for analytic style queries. We needed fast transformation and aggregation of FHIR data at population scale. Secondly, we needed to be able to expose this FHIR data to business users in a way that they could use without having to be experts in the FHIR specification or health informatics. We needed to be able to provide views of the data that would be amenable to self-service business intelligence using the tools that people already had access to. Finally, we needed to make clinical terminology easy to use within the context of analytics. A large proportion of the meaning of health data is held within codes, and understanding these codes and their relationship to one another is critical to the task of properly interpreting the data. Pathling is the solution we came up with to address these problems, and we've been building and refining its functionality ever since. It has a flexible architecture that is designed to support many different analytic use cases. I'm going to explain the different features and provide examples of how they can be applied. We ship Pathling in two different forms, language libraries and a server implementation. The libraries can be used for data science work that might be carried out in Python or R notebooks. They can also add additional capability to data transformation pipelines that are used to prepare data for use with other analytic tools. The server can be used by web and mobile applications that require analytic query capabilities. It can serve as a target for updates from real-time FHIR data sources, and it can also be used for patient cohort selection and data extract services. The Pathling libraries are available in Python, R, Java and Scala. The server is available as a Docker image. Both the libraries and the server can also be plugged into a Spark cluster, either on-premise or in the cloud, to scale out the resources available for query processing. AWS, Azure and Google Cloud Platform all provide cluster services that are compatible with Pathling. There are three main areas of functionality within Pathling. The encoders are what we use to convert raw data from each FHIR resource into a table or data frame that we can run queries over. The terminology functions allow us to query additional information from any codes present within the data. The FHIRPath engine provides a higher level interface to query and transform our FHIR data. It removes much of the hard work that is involved with writing SQL queries and lessens the requirement for knowledge of FHIR specification details. The terminology functions use a FHIR terminology server such as OntoServer, making requests to its FHIR API and merging the results with your data. This allows you to manage your terminology content in the terminology server and set this server up with the content management and access control that you require. Terminology queries can be executed efficiently across large datasets and can be cached according to the policies of the server. The FHIR encoders are the mechanism that we use to get FHIR data into a format that is useful for analytic query. I'm going to take you through how our FHIR encoders work and the features that they provide. The Pathling encoders convert FHIR to a set of Spark data frames while preserving all the information within the source format. Pathling provides a schema for each of the 140 plus resource types within FHIR. Once the data has been converted into a data frame, it is then available for query using Spark SQL or using the FHIRPath query capabilities of Pathling. Data can be optionally persisted using the Parquet format. Parquet is a columnar data format that is optimized for analytic query and is compatible with many different analytic tools. Delta Lake is a variation of Parquet with additional features such as history and transactions. Delta allows you to incrementally update your analytic replica and time travel between versions. The encoders are also capable of generating FHIR back out of the data frame with no loss of fidelity. The Pathling encoders support the use of extension content. Extension content is very common within FHIR data and is used to represent localized concepts that are not present within the base specification. In this example, an extension is being used to record the fact that an interpreter will be required for this patient. This data can be easily queried using FHIRPath, and we'll show an example of this later on. The Pathling encoders also support the representation of nested content. There are several resources within the FHIR specification that have nested or recursive structures within them. An example of this is questionnaire and the associated questionnaire response resource. Another nice feature of the Pathling encoders is that units within quantities are canonicalized for easy comparison at query time. If standard terminology for units is used and those units are comparable, values can be compared without any further processing. In this example, we have two different observations of body temperature captured in Celsius and Fahrenheit. Upon encoding, both values would be stored in Kelvin in addition to their original units. We'll show an example of quantity comparison within FHIRPath later in the presentation. And that's it for the encoders. Now I'll give you an overview of the terminology functionality that we have built into Pathling. Terminology is used extensively within health data and is used to describe many concepts including observations, diagnoses, procedures, medications, and many more. Terminologies such as SNOMED CT are linked to extensive knowledge resources that describe the meaning of codes and orient them relative to other clinical concepts. Terminologies can also provide alternate descriptions of codes, such as synonyms, language translations, or patient-friendly terms. This example is a SNOMED CT code that might have been captured as a diagnosis or medical history item within a patient's record. Rheumatoid arthritis of left knee. If we look up this code within SNOMED CT, we find that there is a great deal of information available to describe it. Hierarchy can describe the relationship between this concept and more general concepts or more specific concepts. This can be useful for capturing related data into categories. Attributes can describe things like the finding site, causative agent, and more. The hierarchy of concepts can be expanded out further to roll this condition up into even more general concepts, such as arthritis or autoimmune disease. This sort of information is very useful for a range of analytic tasks, and this is an example of what the combination of Pathling and a terminology server can give you access to. These are the terminology functions that are available within Pathling, both as SQL functions and also within FHIRPath queries. Member of allows you to test whether a code is a member of a particular value set. Subsumes allows you to test whether a code is a subtype or supertype of another code. Translate allows you to translate between codes based upon predefined maps. Property allows you to query properties or attributes of codes. Designation allows you to query text descriptions of codes, such as display terms, synonyms, and language translations. The terminology functions can be used independently of the FHIR functionality of Pathling. You can use them to query terminology within non-FHIR datasets as well, and we will show some examples of that. This is an example of using the member of function against a SNOMED CT based value set. This dataset is not FHIR, it's a simple tabular extract that you might get from a typical emergency department system. The first argument to the function is the column that contains the SNOMED CT coding. The second argument is a FHIR value set that is known to the terminology server. In this case, it is a SNOMED CT expression that describes concepts related to mental health. The result of the function is a true or false value against every code in the dataset. This could be useful for patient cohort selection or categorization of data. This is an example of using the translate function to convert codes from one code system to another. Here we are converting SNOMED CT diagnosis codes to ICD-10 based on a concept map that we have loaded into our terminology server. In FHIR, you can define concept maps with different equivalence types, and this function allows you to select which of these types will match. You can also optionally translate the map in reverse. This is an example of querying properties of codes. Here we are querying the finding site and associated morphology of each diagnosis code, and we have created 2 new columns to hold this information. This final example demonstrates the retrieval of synonyms. This could be useful for improving recall when using text matching searches over your data. I hope you now have a better understanding of the terminology functionality within Pathling. Now we're going to dive into FHIRPath query, which is where a lot of the features that we've talked about so far come together. FHIRPath is a language that was created alongside the FHIR standard to make it easier to extract data from FHIR resources. Within Pathling, we use it to ease the task of writing queries over the top of FHIR data. FHIRPath expressions are translated into Spark SQL queries that are then run over our encoded data frames. The benefit of using FHIRPath is that it abstracts away some of the tedious details related to navigating nested data structures and dealing with FHIR data types. It also provides a bunch of functions that inject additional capabilities into your queries, such as dealing with extension content and querying terminology. The first example on this slide shows a FHIRPath expression that is extracting the first names for a patient. The where function is used to filter the names to only those with a use code of official. The second example determines whether a procedure was performed after a particular date. The third example selects an immunization record based upon its code and then extracts the date of administration. We've implemented a function within FHIRPath to ease the task of accessing data that is held within extensions. This expression continues from our earlier example to extract the preferred language for a patient that requires an interpreter. Our support for unit canonicalization was mentioned earlier when we covered the features of the Pathling encoders. This example shows a FHIRPath expression that uses the less than operator on a quantity field that may have been captured using different units. Because we already canonicalized these quantities when they were encoded, we can compare them directly without any need for manual conversion. We also expose our terminology capabilities through FHIRPath functions. In this example, we are using this subsumed by function to test whether condition codes are a subtype of ventricular tachycardia. As you can see, there are many different subtypes of this code within SNOMED CT, and this feature removes the need to manually maintain this list of codes and check against it. So now that we have built this FHIRPath capability, how do we use it within queries? We have several operations that enable different styles of queries. The first of these is called extract. The extract operation takes a set of FHIRPath expressions and uses them to produce a flattened, tabular view of FHIR data. Each expression corresponds to a column in the output. Nested data is automatically unnested into multiple rows within the table. There is a subject resource that serves as the origin for each of the expressions. Joins to other associated resources are made using the resolve and reverse resolve functions. In this example, we are creating a simple table of patient details, along with a column that indicates whether they have a recorded diagnosis that is a type of heart disease. The result is filtered to only those patients that have not received a COVID-19 vaccine. The aggregate operation works like a pivot table, taking a set of aggregation, grouping, and filter expressions and providing a set of grouped results. Grouping expressions determine which bucket each resource falls into. Aggregation expressions are calculated across the set of resources within each bucket. Filters constrain the overall set of resources that are included in the query. In this example, we are counting the number of patients by the type of diabetes that they have been diagnosed with. The query is filtered to female patients only. We have also been working with a group of international collaborators to create a new companion standard for FHIR called SQL on FHIR. Within this standard, there is the concept of a view, which is an implementation agnostic definition of a flat table that has been projected out of FHIR data. We used FHIRPath expressions to define each of the columns within a view. This is similar to the extract operation that I mentioned before, and we are building out the Pathling SQL on FHIR implementation alongside our existing functionality. The existence of this standard will enable the sharing of reusable, use case-oriented view definitions, and it will create a common interface to view runners that can be run against many different query implementations. And that concludes our summary of FHIRPath query within Pathling. Next, we are going to talk about Pathling Server, which exposes this functionality within a FHIR-compliant API. Pathling Server is a FHIR server implementation that provides a set of operations that are focused upon analytic rather than operational use cases. Data that is imported into a Pathling server is saved as Parquet files rather than tables in a relational database. You can query this data using the FHIRPath query operations I mentioned earlier, but through a FHIR API rather than using a Python or R library. You can also use the server for data ingest. Updates made through the FHIR API are incrementally merged into the Parquet files so that your analytic queries can reflect the latest changes. History is also kept, which allows for querying the state of the data at a point in time. Pathling Server is distributed as a Docker image, and we also publish a Helm chart for deploying this image to a Kubernetes cluster. It can be configured to run as a single instance or to spawn worker nodes to process data in parallel. It serves as both a FHIR API that standard clients can communicate with and a general purpose Spark cluster that can run jobs that are defined using any of the supported languages. And that concludes my overview of the functionality provided by Pathling. In summary, Pathling allows you to query FHIR data using either SQL or FHIRPath. It allows you to incorporate sophisticated use of terminology within your queries. It provides APIs that you can use to power FHIR-based applications. And it also assists with the conversion and transformation of FHIR data for use in other analytic tools. All of this is open source and is free for both commercial and non-commercial use without restriction. If you do make use of Pathling, you can help us by getting in touch with us and letting us know what you are using it for. Case studies help us to better understand user needs and help us to justify further investment in the product. If you need any help with using Pathling, you can reach out to us and other members of the Pathling user community on GitHub or through the FHIR community chat. Thank you for your interest and attention, and feel free to get into contact if you have any questions. You can also learn more about Pathling at our website, pathling.csiro.au.